today we will start our next chapter, that is chemical bonding. This is chapter number 4 of class 11. Now, chemical bonding, as the name suggests, it is related to chemical bonds. And you know, chemical bonds are formed between atoms. So, first question is, why do atoms combine? Atoms combine क्यों करते हैं? तो सबसे पहले जो कॉसेल और जीएन लुइस उन्होंने सोचा कि नोबल गैसेस जो हैं they exist independently and rest of the atoms they combine to form a molecule containing same atoms or different atoms. So question arises कि why do other elements, other atoms combine and noble gases are independently existence. Noble gases have independent existence, like you know, helium, neon, argon, krypton, xenon. When we see their configuration, you know, helium is 1s 2. This is helium 2s2 2p 6. Argon, neon 3s2 3p 6. Krypton, argon 3d10 4s2 4p 6. Then krypton and 4d10 5s2 5p 6. Likewise, so you can see the pattern. In the valence shell there are 8 electrons, except in helium where there is duplet. In the rest of them, in the valence shell there is complete octet of electrons. There are 8 electrons. In neon, in the second shell there are 8 electrons. In argon, third shell has 8 electrons. Krypton, in the fourth shell there are 8 electrons. In xenon, in the fifth shell there are valence shell, outermost shell has 8 electrons each. Okay, so that will give rise to octet rule. So first theory to answer this why do atoms combine is because of octet rule. So what is octet rule? That atoms can combine either by transference of electron, by sharing of electrons, in order to complete their octet. That is called octet rule. There are so many limitations of this rule, but octet rule is successful in explaining many things about the chemical combination of the atoms. First of all, if you say the electronic configuration of noble gases, every atom tries to attain noble gas configuration. Okay, and that's why atoms combine to get stable outermost shell, stable configuration in the outermost shell. Okay, so first of all, let us discuss Kossel-Lewis approach. Kossel-Lewis approach to chemical bonding. 1916, G.N. Lewis and Kossel stated that atoms can combine either by sharing of electrons or by transference of electrons in order to complete their octet or in order to attain noble gas configuration, and that's the reason they combine with each other. Okay, so they can form, in case of diatomic, they can form homodiatomic or heterodiatomic molecules, or maybe more than that. But in case of diatomic, there are two types of molecules: homodiatomic and heterodiatomic. Homodiatomic molecules means molecules having same atoms. For example, H2, O2, N2, Cl2, so on. Okay. Heterodiatomic means molecules having different atoms. Two atoms of the molecule are different. For example, HCl, okay, CO, HF, and so on. This is called octet rule. This statement, okay, you know now the homodiatomic and heterodiatomic. So this statement, this is called octet rule, right? Okay. Now you can say that atoms actually combine to acquire noble gas configuration. This is the octet rule, and in case of helium, that is duplet. For hydrogen, octet rule is not applicable, so rule of duplet is applicable because helium has 2 electrons. Except helium, all other noble gases have 8 electrons in their valence shell. That's why octet rule is covering wide number of molecules. Okay. Now, Lewis symbols for representing valence electrons. Okay. For example, if we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, these are ordinary symbol of atoms. In lithium, we have how many valence electrons? 1. So, these dots represent the number of valence electrons. So, with dot, it becomes Lewis symbol, and this is also known as electron dot symbol. to write like this. Okay. Lithium has one valence electron, so one dot is representing the Lewis. Lithium is ordinary symbol, and lithium with one dot is Lewis symbol. With two dots, beryllium with two dots, that is Lewis symbol for beryllium. Boron with three dots, carbon with four dots, nitrogen with five dots, oxygen with six dots, fluorine with seven dots. Okay, so these are called valence electron. So valence electron, these are the Lewis symbols, and valence electron is equal to number of dots. Also called Lewis symbols or electron dot symbols. Okay, you know electronic configuration of each one of them. Okay, for example, for sodium, this is the ordinary symbol for sodium. So with one dot, that become its Lewis symbol. Right? So I think you can write Lewis symbol for any atom. Am I right? Okay. Now, significance of Lewis symbols. What is the significance of Lewis? So Lewis symbols are the element with, means symbol of the element with dots representing number of valence electrons. What is Lewis dot structure? The ordinary symbol of the atom with number of dots equal to number of valence electrons. Right? Now let us discuss the significance of Lewis dot. Lewis dot structure. Okay. Here simply Lewis symbol. So significance, first is they represent number of valence electrons. Means number of dots represent number of valence electrons. Second, valence is equal to either n or 8 minus n. N if n is less than or equal to 4, and 8 minus n if n is greater than 4. Okay, and n is number of dots or equal to number of valence electrons. And you know valency means combining capacity of an atom. Valency is combining capacity of an atom. Then third is Lewis symbol of, for example, you know that Lewis symbol of nitrogen is Lewis symbol of oxygen is O. It is like this. That means number of valence electrons, that is equal to number of dots equal to 6. And what is its valency? Because it is greater than 4, so valency is 8 minus n, so valency is 2. So in this way we can calculate valency as well as valence electrons. So there is a lot of information hidden in the Lewis symbol. Okay, and that will also give us an idea that how many electrons it needs to complete its octet. Say it has 6 electrons. So how many electrons it will share to complete its octet? Obviously 2. So it's combining its valences 2. Right? So in this way, this is what we can predict or we can determine by looking at the Lewis symbol. Okay? So this is significance of Lewis symbols. So if question is what is Lewis symbol and what is its significance, you can write like this. It is most simple question, a most simple chapter, most informative chapter, most basic chapter, and very important for the even competitive exam. Okay, so every lecture is very important for chemical bonding because it is used in class 12th as well. Some facts stated by Kossel in relation to chemical bonding. So first is stated that halogens and alkali metals, they are separated by noble gases because they are extreme right and extreme left. They are to the extreme left and extreme right. Okay, separated by noble gases. That's why they are most electronegative and most electropositive. Alkali metals and halogens. Alkali metals are most electropositive, halogens are most electronegative because halogen needs 1 electron to complete its octet and alkali metals lose 1 electron to attain noble gas configuration. That's why both are most reactive elements. So first is in the periodic table, highly electronegative halogens, that is group 17, and highly electropositive alkali metals, that is group 1, are separated by noble gases, separated by noble gases, that is group 18. So this is the first statement or fact given by Kossel that in the periodic table highly electronegative halogens, that is group 17, and highly electropositive alkali metals, that is group 1, are separated by noble gases. Okay, that is separated by noble gases, and these are means halogens are present in the extreme right alkali metals to the extreme, left separated by noble gases. Okay, this is the first statement. Then atoms of the element, this is the first fact. Atoms of halogen family. Atoms of halogen family means fluorine, chlorine, bromine, iodine. Okay, so the atoms of halogen family change into anions by gaining one electron, and atoms of alkali metals lose one, alkali metals change into cations by losing one electron. This is the second statement. For example, sodium. You know Lewis dot structure of sodium is this. So after losing one electron, it is cation, and chlorine, it has 7 electrons. So after gaining one electron, it form anion. Halogens form anion, alkali metals form cations. Both cations and anions acquire noble gas configuration. Acquire noble gas configuration, right? Because you know sodium has 11 electrons. So after losing one electron, it acquires configuration of neon, and chlorine has 7 electrons. After gaining one electron, it acquires noble gas configuration of argon, right? Okay, so now the negative and positive ions are stabilized. The negative and positive ions are stabilized by electrostatic force of attraction between oppositely charged ions, which is called, this is called electrovalent bond. This is the statement of electrovalent bond, or we can call it as force of attraction between positive and negative ion, between cation and anion, is known as electrovalent bond or ionic bond. So these are the facts stated by Kossel. Means Kossel give us information about the ionic bonding between the atoms. Okay, after formation of cation and anion. Okay, and electrovalency. Electrovalency is number of electrons gained or lost by an atom in the formation of cation or anion. For example, what is the electrovalence of sodium? You know, sodium is Na1 plus, so it loses one electron. So we can say it is number of positive or negative charge on the ion. Okay, so sodium has electrovalence of 1. Cl, again it gain one electron, so its electrovalence is again 1. It is number actually, magnitude. Okay, it is electrovalence is not -1. It is 1 because it gain one electron, it lose one electron, so it is number. Okay, so tell me, what is the electrovalence of magnesium and aluminium? So magnesium, because it loses 2 electrons, that's why electrovalence of magnesium is 2. Aluminium, you know, it loses 3 electrons to acquire noble gas, so its electrovalence is 3. Electrovalency of sodium, magnesium and aluminium is 1, 2 and 3 respectively. Now, how many types of bonds are possible? So you know, there may be covalent bonds, there may be ionic bonds, there may be coordinate bonds. Covalent, coordinate bonds. So let us discuss about them. Okay, so modes of chemical means types of chemical bonds. Types. So as I said, covalent bond, coordinate bond and ionic bond. So first is by electron transfer. Electron transfer means by gaining electron or by losing electron. Okay, so this electron transfer, so the bonds we have discussed now, only the bonds formed by transference of electrons. Transference of electron is gaining or losing electron. Ionic or electrovalent bond. That we have discussed. Okay. Second is by electron sharing. by electron sharing, one sharing is equal contribution from both the atoms. Means if first atom contribute one electron, then other atom also contribute one. So that is called mutual sharing of electrons. Okay, so that sharing is called, the bond formed by mutual sharing of electrons is known as covalent bond. Second is the bond formed by mutual sharing of electrons is called covalent bond. Okay, and third type is, it is again sharing of electrons. The bond formed by sharing of electron, but shared pair is provided by only one atom. Both share, but shared pair is provided by only one atom. That is called coordinate bond. Okay, now I will explain what it means. See, first type, ionic bond. Let us have sodium and chlorine. So you know, sodium has one dot, means one valence electron, and chlorine has 7 valence electron. So if this sodium transfer its electron to chlorine, both acquire noble gas configuration. Sodium becomes sodium 1 plus and chlorine becomes chlorine 1. So this electrostatic force of attraction between this cation and anion is called ionic bond, because this bond is formed between oppositely charged ions by the transfer of electrons between the atoms. Okay, second, let us take nitrogen. Nitrogen has 5 valence electrons. Other nitrogen also have 5 electrons. Both need 3 electrons to complete their octets. Actually, covalent bond is formed between non-metals. So say, if they share 3 electrons with each other, means there is a mutual sharing of equal number of electrons. So this type of bond is called simple covalent bond. Okay, now third type. Third type is, for example, we have see, nitrogen can form 3 bonds. Okay, let me have this whole space. See, nitrogen, you know, it has 5 valence electrons. Out of 5, it needs 3 more to complete its octet. So now see, if one hydrogen is there, you know, hydrogen has 1 electron and it needs 1 more to acquire configuration of helium. So it will share one electron. So in this way, each hydrogen form one covalent bond. Means this is the structure. It has 3 shared pair and 1 unshared pair. 3 shared pairs and 1 unshared pair. This is also called lone pair. Now let us talk about boron. In boron, you know, it is like this. Boron has 3 valence electrons, right? So it can form 3 bonds with any other atom like fluorine. Fluorine has 7 valence electrons. It needs 1 more electron to complete its octet. So in this way we get BF3. See here, this ammonia has octet of electrons. Ammonia has 8 electrons in its valence shell. 1, 2, 3, 4 pairs. In total 8 electrons. So ammonia has octet in ammonia, in, is it visible? Yes, in ammonia nitrogen has octet of electrons, and at the same time it has 1 unshared pair. Such a molecule is called electron rich molecule. Any molecule in which central atom, this nitrogen is central atom, has complete octet of electrons and has unshared pair. So that is called electron rich molecule. Okay. So ammonia is electron rich molecule. Got it? Now come to BF3. In BF3, can I write? Yes. In BF3, boron has 6 electrons. It has sextet of electrons. Means, say first is electron rich because it can donate this pair. So it can share this pair with any other molecule, not donate, but can share. Okay, but BF3, boron has 6 electrons. It is deficient of electrons, means it has not completed its octet. So such molecules are called electron deficient molecule. Means any molecule in which central atom has less than 8 electrons, that is called electron deficient molecule. One is electron rich, other is electron deficient. So electron rich can donate its pair or can share its pair with other molecule or atom. So such a molecule which is electron rich is called Lewis base. That is called Lewis base. And this molecule, because it has tendency to gain electrons, the one which has tendency to lose electron is called Lewis base, and the one which has tendency to gain electrons is called Lewis acid. Is it visible? Yes. So I can write it is Lewis acid. So Lewis acid is one which can gain electrons. One which can gain electrons is called Lewis acid, and one which can donate electrons, that is called Lewis base. So now let us write them like this: nitrogen of ammonia with one pair, boron of Bf3 without any electron pair, and it needs two more electrons. Now there is a compromise. See, this nitrogen, if it share this whole pair with boron, like there is a sharing, but shared pair is given by the single atom. Such sharing leads to the formation of bond, a special type of bond, and that is called coordinate bond. That is called coordinate bond. And this arrow indicates the donor and acceptor. The arrow is from the donor to the acceptor. Means this donate the whole pair for the sharing, and this will accept the shared pair of electrons without giving any single electron. But what is the benefit of doing that? Both have octet of electron now. Both have octet of electrons. इसमें किसी का कोई घाटा नहीं है, ठीक है? Rather, BF3 got satisfied by forming this type of bond, because earlier only ammonia has, in the central atom of ammonia has complete octet of electron, but once the bond is formed, both nitrogen as well as boron, now they both have complete octet of electrons. And one more thing, once this bond is formed, there is no difference between covalent and coordinate bond, but coordinate bond is slightly stronger. Why is it so? Because if we write it like this, then boron gets negative and nitrogen gets positive charge. So there is covalent bond when one electron is shifted from nitrogen to boron. Like see, nitrogen with one electron, so it gets positive charge. Boron with one electron, so it gets negative charge because it gained one electron. Now this is sharing. So if we form simple covalent bond, then donor gets positive charge and acceptor gets negative charge. So this is also the symbol which represents this arrow. If we write arrow, then there is no charge shown on boron and nitrogen. But if we form simple covalent bond, then acceptor gets negative charge and donor gets positive charge. So these are the symbols for coordinate bond. So coordinate bond is slightly stronger because of this development of charge than the covalent bond. and you know ionic bonds are strongest, right? Doubt up to this, please ask. Yes, gallium F3 is also the same, but you know gallium is very large in size and fluorine is very small in size, right? And we will see the conditions of bonding. Actually, orbitals belonging to the same shell form stronger bonds having same energy. Okay. Okay, no doubt up to this. So let's stop here today. We have completed today Kossel approach of ionic bonding, and sodium chloride we have prepared. Let us do one more, that is for calcium fluoride, and then we will stop our discussion for today. Coordinate bond, I think you could figure out. One more example I can give, like ammonia and H plus. So you know H plus means with no electron. So if it form bond with H plus, there should be a coordinate bond, because bond is formed between nitrogen and hydrogen, but hydrogen will not contribute. Okay, if hydrogen will not contribute, obviously nitrogen will give its pair for sharing. So this is the case of NH4 plus. So NH4 plus has 3 covalent bonds and 1 coordinate bond. Okay. Now CaF2. CaF2. Yes. So in CaF2, you know calcium has 2 electrons. Am I right? Fluorine has 7 electrons. So calcium will donate 1 electron each to fluorines. So calcium is 2 plus and F 1 negative, F 1 negative. So in this way, the ionic bond formed between calcium 2 plus and fluoride ion. Okay. And what is the electrovalency of calcium? So electrovalency of calcium is equal to electrovalency of fluorine as well. 2 and it is 1. And this is called electrovalent bond or ionic bond. Okay, bye bye.